We are recording right now. All right, so I'm going to throw some questions out there about things I put up on the screen, and I want you to respond, okay? So I'm going to ask you, that first one I think was cranberry juice, okay? I'm going to make a statement about cranberry juice, and I want you to respond. Cranberry juice is an element. Cranberry juice is an element. Cranberry juice is an element. Okay, so I'm going to say no. Cranberry juice is not an element. It is made of many different things, right? How about baking soda? Let's do baking soda. There's pure baking soda. What would pure baking soda be? I'm sorry, let me make a statement. Pure baking soda is a compound. Pure baking soda is a compound. 50-50 there. Well, it's kind of tricky the way I said it, right? Because I said pure, and it is a compound. Okay, it is not an element because it's made of more than one atom, right? Or type of atom, I should say. Okay. Let's do one more. How about water? Ooh, there you go. Pure water is an element. Pure water is an element. Pure water is an element. Again, 50-50. Well, I will tell you, everything on that sheet is a compound, right? Made of more than one type of atom, including water, H2O, right? So, yep, hydrogens and oxygens, for sure. For sure, okay? So we're going to talk a little bit more about that, but today we're going to talk about what makes up matter. I don't think we're even going to get into bonding today. I know we aren't. We're just going to be talking about the periodic table, some basic stuff. I have to review certain things with you if I expect you to be able to bond in this class. What? Okay. Oh, yes. We're going to get very close. We're going to bond, of course. Yes. So every living and non-living thing we know is made of matter. We're made of matter. Okay, we know that. Everything around us contains matter. And matter is basically anything that takes up space. If you go up into space, is there any matter there? No, it's just space, right? That's why we call it space. Space is the absence of matter. That's simply put. So we know all matter is made up of very small particles called atoms. We know an atom is the smallest unit of matter that cannot be broken down by any chemical means. Do you guys know you have about 4 elephants on top of you right now worth of matter? Yeah. Yeah. You guys are like super people. If you added up all the weight or the mass that's on top of us right now, from here to space, that's like 4 elephants worth right on my head. Okay. That's a lot, right? Yeah, that's why we're so strong. But really, if you go to the moon, you can pick up a car, right? No big deal. Okay, so think about it. Less matter on top of you there. You can pick up all that weight that's no longer there. No more gravity, too. That also comes into play. Okay? But just think about, Superman. He was from another planet, right? That had a really dense atmosphere. Then he came to Earth. I don't know if any of you are up to date on your Marvel comics. That's why he can, fly around, right? Now Superman makes sense. Of course that's what happened, right? If he were real, that would make, you get the idea though, right? So if I went to, let's say, a very less dense planet than Earth, we could fly too. Leap buildings with a single bound, all that. Something like, yes, okay, but how do you know? How do you know he didn't jump to start that whole flying interaction? Okay, yes. I am going to sell those and then just shoot people up. Yes, that's a good scheme. I've never seen it, but someday maybe. So you can buy tickets to the moon right now, but they don't have the shuttles yet to get you there. They're building them, so there's going to be commercial flights to the moon. That is coming in our future, but people have pre-bought those so that they can build the ships, basically. Like $1 million tickets, right? So an atom has a pot. We're getting way off topic, okay? So an atom has a positively charged core surrounded by negatively charged regions. And that region is called the cloud, right? We know that. All right, folks, get focused. So the nucleus of an atom is made up of positively charged protons and uncharged neutrons. Pro for positive, nu for neutral, neutron. Negatively charged electrons have very little mass and move around the nucleus in a large region called the electron cloud. Now, this should all be a review. You all should be yawning right now. This should just be me talking about some basic subatomic particles that you remember from physical science. Okay? Had a couple people who weren't here. I want to make sure I get notes to. Yep. Here's a question for you. If I'm an atom and I'm balanced, and I have, let's say, 10 protons, how many electrons do I have? Please type it in. If I have 10 protons, how many electrons do I have? If I have 10 protons, how many electrons do I have? Protons are positive, electrons are negative. If I have 10 protons and I'm an atom, how many electrons do I have? Come on now. It's okay to be wrong. I won't judge you. Let's see what's coming in here. 5, 5, 10, 0, 10, 9, 10, 10, 10. It is 10. Okay. Most of you got it right. We'll talk about why in a minute. Now, an element is a substance made up of atoms that have the same number of protons. So if I look at this periodic table, and I look over here at number 10, it's neon. Everything here has 10 protons. If I have 10 protons, how many electrons do I have? 10. Protons are positive, right? Electrons are negative. What's plus 10 added to negative 10? What is that? 0. So that means all elements are balanced at 0. If they have a charge, they're no longer an atom. What are they called? Please type that in. What are they now called? If you have a charge, you're no longer an atom. What are you? What are you? Get focused. Type it in. Be wrong. It's cool. Kind of. It's okay to be wrong, right? You don't learn anything from being right. You already knew that, right? If you are not balanced, meaning you do not have an equal number of protons and electrons, what are you? Type it in. Either you know it or you don't. We're going to go over it. Don't worry. If you have a charge, what are you as an atom? You're no longer an atom. What are you? Let's see what we have. No, not isotope. We'll get there. That's a different thing. Oh, dear. Ion. Ooh, there you go. Or anion or cation. Very good. There's two right answers. Okay. Cation and anion are two types of ions. Boy, if you're talking right now, you should be focusing because hardly anybody knew that from last year, and you should have taken that in. Ions are charged particles. They are not atoms. Okay? If I have an extra electron or I'm missing an electron, I become something special called an ion. I'm no longer an atom. Okay? You can't trust atoms. You know why? They make up everything. All right. So the electron cloud of an atom may have levels. We understand the levels on the periodic table a little bit. I'll tell you the basics that you need to know for this class tomorrow when we get into bonding. But electrons in the outermost level or shell are what are called valence electrons. And it is indeed those outermost electrons that we get into when we look at bonding. So atoms tend to combine with each other in such that 8 electrons will be in each valence shell, except for what? The inside, right? The very first one. How many does the first one hold? I'm going to ask you, how many does the first one hold? Please tell me. How many does that first level hold, type it into Peardeck, be wrong. It's cool to be wrong. If you're right, you already knew it. You didn't learn anything. Yeah. Let's see what we got. 2, 2, 2. Oh, I said 2, 2. Chugga, chugga, 2, 2. All right. Oh, 6. 1, 3. Well, the answer's 2, right? Now, let me just talk about that real quick. We're going to get into more of this tomorrow, but remember, in the very center is the nucleus, of course. I'm just going to put an N, okay, for now. That inside level, please focus. Ooh, that's sloppy. Can only hold 2 electrons. That's what that E stands for, right? Okay? And for this class, because I don't care about chemistry as much, the outside levels can only hold how many after that? 8. Now, in biology, we only really deal with the first 20 elements on the periodic table. Because those are the simplest elements on the periodic table, and life really, when it comes down to it, is not that complicated. If we were made of all of these, we would be extremely unstable. Does that make sense? Okay? And so our rules are really simple with the chemistry we have to do in here. The first level holds how many? 2. How many does it hold? 2. Every level after that holds 8 for this class. It will change in chemistry later. Okay? I don't have all the time to get into electron configuration. That's a chemistry topic. You can deal with that with Ms. Schaefer next year. Okay. So, where did we get to? Oh, atoms tend to combine with each other in such a way that 8 electrons will be in the valence shell, except for that inside level holds 2. Now let's look at the periodic table up here. We have hydrogen, and we have who in the first row? Helium, right? What's helium's atomic number? 2. How many protons does it have? 2. How many electrons does it have? 2, right? Is it happy? Is its outer shell full with 2? Yes, because the first level holds 2. That's why that first row has 2 elements, right? We good there? Look at the next row. 1, 2, 3, 4, 5, 6, 7, 8. Oh, now it makes sense, right? Let's go to the next one. 1, 2, 3, 4, 5, 6, 7, 8. That's the third level, right? Remember I said we won't have to go past 20, so I won't worry about all those fancy orbitals that you'll get into next year. That's not a biology thing. We don't worry about that in here. So when atoms combine, a force called a chemical bond is going to hold them together. All right? We're going to get into a few different types of bonding. I'm going to see what you know from last year. I'm going to kind of test you a little bit here. What type of bond shares electrons? Type it in. What type of bond shares electrons? Don't talk, type. What type of bond shares electrons? I should see way more than 2. Let's go. It's okay to be wrong. Somebody put male bonding last hour. It's okay. Oh, isotopes. We haven't gotten there yet. Let's see what we have. Covalent is correct. I have no idea. It's an honest answer. Covalent, covalent, covalent. Yay. Hey, when you share something, ooh, not ionic. We'll talk about ionic later. When you share something, are you stronger when you share something? Yeah. What if you take something from someone? Are you very strong then? No, one of you is weak, right? And so we'll talk about that. That's like ionic bonding, okay, where you give electrons away. There's other types of covalent bonding. You guys probably remember polar covalent bonding a little bit, okay? We'll talk more about that, especially in this unit. We'll do a water lab. That'll be fun, okay? You'd be like, what are you talking about, Mr. Mason? I'll be like, yes, exactly. Water. Yeah. All right, you guys. Today, though, I'm going to stop here, okay, for a reason. we need to actually do some periodic table stuff.